So we are going to talk about max terms now. Okay, so we learned about min terms in the last few videos, and we learned that in min terms, whenever a truth table is given, okay, let's say we have A, B, C, and the output is Z. Okay, whenever the truth table is given, the output, if the output gives out one, okay, if the output gives out one, what we do is we have to, we have to identify the min term by for that specific combination. For example, in this case, 0, 0, 0 means the min term will be A bar, B bar, C. Okay, so this is the min term for that specific combination. And then after finding all the min terms, wherever the output is 1, we will find the min terms. And then finally, we write down the output as a sum of products. That's how we use min terms. I hope you remember. But when we are talking about max terms, it's a little bit different. Okay, so first of all, let's look at an example so that you will also be able to understand what I'm trying to say. So this is the truth table that is given to us. Okay, so you can clearly see there are 8 rows or 8 combinations. When you're working with max terms, what you have to look for is whether the output is 0. Okay, we don't think about the output 1 because the combination will give us the min term. We are looking for output 0. So this is where we can find a max term. This is where we can find a max term. This is where we can find a max term. And this is where we can find a max term. Okay, so these are the different max terms that we are going to find out. So when we are working with min terms, we considered 1 as present, okay, 1 as present and 0 as not present. Okay, so if we had 0 in min term, we would say not A. Okay, if we had 0 here, that is not B, right? That's what we did. But in max term, what we are going to do is, if 0 is there, that means A is present. Okay, if 0 is there, A is present. Okay, and then B is also present, C is also present. Why? All the signals are 0 for each of the given variable. Okay, what should we do after this? Well, since we are going for max term, okay, since we are going for max term, we are using product of sums. Okay, we are using product of sums. So here what you have to do is, you have to put the plus symbol. Okay, the or symbol, the plus symbol, that's what you have to put. So similarly, we can do for the second combination. Here we have A plus B plus C bar. Okay, instead of C, we are going to put C bar. Why? There is a 1 here. Okay, similarly, here also we can do that. Here we have A, but we have B bar. Why? The signal B is 1 here. Then we can put C without any issues. Similarly, this is also A bar plus B plus C. Why? Signal A is present, which means we have to put not A for max term. 0 is there for B, 0 is there for C, so plus B plus C. So these are the max terms. Okay, so these are the max terms. These are the max terms. Once we know this thing, okay, once we know what are max terms, what we can do is, we can come up with the expression. Okay, so Z can be given as A plus B plus C into A plus B plus C bar into A plus B bar plus C into A bar plus B plus C. So this is the expression Z. Okay, so this is the expression Z. What should we do after this? Well, if you want to, you can actually simplify this. Okay, you can actually simplify this. And from what we had studied in distributive law, if you remember, I'll just attach the video, of course, because we know that A plus B plus C into A plus B plus C bar can be given as A plus B plus C bar. I don't know whether you remember this, okay, but we can give like this. I'll attach the video to the link. Actually, I'll attach the link to the description so you can understand what's actually happening here. So C bar is equals to 0, so this is equals to A plus B. Okay, so that's the idea here. So if I simplify this, Z can be given as A plus B into, here we have A plus B bar plus C, and here we have A bar plus B plus C. So what can we do? What can we do? Well, we can write it down as C plus A plus B bar into A bar plus B. Okay, so what am I doing here? Well, here if you see, C is the common term that's present. So I have written down C here. Like when we did with this, we had A plus B as the common term. So I put A plus B here. Then we multiplied C and C bar, which gave us 0 according to the inverse law. And then we came up with A plus B. Okay. Similarly, here C is the common term, C is the common term. So I have put C here. I have multiplied or produce written in the form of products A plus B bar into A bar plus B. So this one we can actually expand. I think do we have to expand this? Yeah. If we expand this, what will we get? So this is A plus B into C plus A bar is equals to 0. So I don't have to do that. We have AB. Then we have B bar A bar. So plus A bar B bar. And then B bar B, which is equal to 0. So this is what we have. After this, what can we do? Well, let's expand everything. So that will give us AC, AAB, but AAB can be given as AB, and then A bar, B bar. A bar is equal to 0, so we don't have to mention that. Then we have BC and then ABB, so that can be given as AB, and then A bar, B bar, B bar is equal to 0, so we don't have to write that down. And we can remove AB since it is recurring. So the final output will be AB plus AC plus BC. So Z can be given as AB plus AC plus BC. Okay, so this is the idea behind this. Okay, so this is the idea behind this. So what did I do? First of all, I found out what are the max terms. This is step 1. Okay, and then I wrote down the max terms, and then so this is step 1, finding the max terms. Let's say this is the step 1. Then writing down the max terms, that is the step 2. Then I can say that step 3 is writing down the expression as a product of sums of the max terms, and then we simplify by using what we have studied until now. So that is step 4, and then we can simplify that, and then we can come up with the obviously we can come up with the circuit. Okay, so how can we draw the circuit? Well, I'll teach you. So here you can see how I have drawn the given expression. Okay, so we have Z is equals to AB plus AC plus BC. So AB has to go through an AND gate. So I have done that. So here we have AB as the output. And then we have the A and C going through an AND gate. So that will give us AC. And finally, B and C passing through an AND gate, which is equals to BC. And the output Z can be given as AB plus AC plus BC by using AND OR gates along with them. Okay, so this is the idea of max terms. Okay, so this is the idea of max terms. Now let's try another question. Okay, now let's try another question just to make sure that we are clear about what's going on. So this is the truth table that is given to us. So first of all, we have to identify the max terms. So this is a max term, this is a max term, and this is a max term. Now we have to write down the max terms. Yeah, we have to write down the max terms. So that will give us A plus B bar plus C. And here we have A bar plus B plus C. And finally we have A bar plus B plus C bar. Okay, so Z can be given as A plus B bar plus C into A bar plus B plus C into A bar plus B plus C bar. Okay, and now what we can do is we can rewrite this to we can rewrite these two into a single product of sum form. So it will be A plus B bar plus C into A bar plus B. Okay, so we have A bar plus B, A bar plus B. Here we don't have any identical signals. So what we can do is we can remove the brackets. First of all, we will have A bar. Okay, I'll just write them down. First of all, I'll just expand everything. Okay, so now you can see we have A bar, AB, A bar, B bar, B bar, A bar, C, and BC. Actually, we can remove A bar, Y, it is equals to 0, and then B bar, Y, it is equals to 0 also. So finally, we will be left with AB plus A bar, B bar, plus A bar, C, plus BC. Okay, now what can we do? Well, can we simplify this? Well, if we think about that, let's try and simplify this. Since we don't see anything like, do we see anything distributive law, anything like that? No distributive law, obviously. What else? What else? What else? What else? Do we have anything else? No, just this. Yeah, because we don't have any redundancy law, obviously, because yeah, there is no single term, so we can't have redundancy law. Yeah, I think we can stop here. Yeah, if we stop here, this is the final answer, and now we can draw the circuit for this. So let's have the signal lines. So we have A, B, C, and let's draw the signal lines. We have A, we have B, and we have C. First of all, we have to pass A and B through an AND gate. So let's pass that through an AND gate. Then we have to pass through A bar and B bar through an AND gate. So what I can do is I can draw a NOT gate and then pass through. Similarly, here also we can do the same thing. We can pass them through AND gate, and then we have A bar C. So I'll just take A bar and pass it through here. So won't be an issue. And then we need BC, so that's not an issue. Why? We have unlimited supply for B and C. So that's it. Now what we can do is we can pass everything through an OR gate. Okay, now we can pass everything through an OR gate, and that will be the output. That will be the output Z here. Okay. So this is what you have to do when you're facing questions where they explicitly ask you to solve by using max terms. Okay, it's pretty straightforward. It's like min terms, but in min terms we work with ones, but in max terms we work with zeros. That's all you have to keep in mind. Okay, so in the next video we will be looking at how we can convert from SOP to POS, because that's very important. When we are doing these questions, you should be able to interchange them without any problems. So yeah, stay tuned.
Thanks for watching the 19th video in our Logic Gate series. If you found this step-by-step guide to solving truth tables using max terms helpful, don't forget to like, share and subscribe for more lessons. Hit the bell icon to stay updated with our latest videos, check out the full playlist to master Logic Gates, and follow us on Instagram. I will see you in the next video. Until then, keep learning and stay curious. Bye-bye.